have discussed about the basic concept of instrumentation, very basic concept that's been related to the construction of instrument, general concept of designing instruments, and their functions, functional elements, as well as some electronic circuits which are usually considered to design functional elements. And some of output device I named them. I have not said their configurations. And also, I have taken example of two systems. One is electrodynamic displacement measurement transducer. One is burning with pressure measurement devices transducer. I have drawn their block diagram. I have shown you that block diagram. And as well as I tried to explain the functional element of each of the blocks. Okay. And also I discussed classification of transducer or measurement systems. Classification based on their operation, based on their working principle, based on their application. So many based on the parts of it. So many things are there depending on what there are different kind of instruments. Some might be called power operated, self operated. Some might be called active, passive, and ideologic, analog, digital. So I have so many things: hydraulic, mechanical, pneumatic, electrical. So many things are there. Fine. Now we came to a particular characteristics. Now you just think about the all things means all electronics and instrumentation component. There are basically four important parts which you have to know, which you must have to know. Better I say must have to know. First one, first one, its construction as well as the visualization. Visualization means what kind of it's actually look. Its look that you have to visualize. That means you have to have a clear visualizations of particular instrument. Second is its construction. Definitely the construction having some important material constants, like some instruments are require a very good platform made of stainless steel. Some instruments require some requires a tagging, proper tagging. So many things will be there when we will discuss of instrument by instrument. You will understand. But construction generally a very important part as well as its visualization. Second part is that its working principle. That working principle more or less actually derived from physics. Derived from physics. The physics means the physics is studied in class 9, class 10, class 11, class 12 standard, even first year basic physics. What you studied from there, the working principle are mainly developed. So that's why the instrumentation and electronics part or all the part of engineering actually called applied physics. All the part of engineering actually called applied physics because there is a certain concept of physics and according to what the systems are designed. And last part definitely that is application. Its applications. Okay. So there would be ম্যাডাম আরে আমি ক্লাস নিচ্ছি কালকে ফোন করেছিলাম বিশ্ববিদ্যালয়ের আদর্শে আজকে এসেছি সবাইকে ডাক শুরু হয়েছে এখনো আমি কি কটা ক্লাস করবো না ঠিক আছে আমি ক্লাসটা নিই তো as I said you that application means where we are going to use the instrument. And obviously, there's the other part that is the fifth part that I have not said in my proof of right part. The fifth part is that there will be certain limitation as well as advantage of instrument. Okay, so this five part is very much important when you are going to use the instrument. When you are used to use the instrument. So if we are talking about the application, definitely when you are going to apply the instrument, you have to keep the concept of limitation and advantage of the instrument in your mind. Secondly, some particular characteristic of instruments. These are not only a case of instrumentation or selection of the instrumentation, they are also important part of selection of electronic or electrical component for your circuit also. These are important. Okay, so that part of selection of instrumentation depend on which area it will be used, and definitely what are its perfect static characteristic as well as dynamic characteristic. Without what a instrument cannot be used. Likewise, you probably heard the term, as I said earlier, the temperature measuring device like thermocouple or thermistor or RTD or thermometer. Do you prefer RTD to measure your body temperature?
No, sir, thermometer.
Very good. No. Why not? Why not? Could you answer? I don't need an accurate answer. I don't need. When I will ask you answer, I
Sir,
don't need any accurate answer. You better say wrong answer. If you know
sir,
the
a
right
thermometer is used generally to measure because it's more easy to like. But the RTD is used for industry grade measurement of temperature and stuff, so that is not very apt.
Mustafa, I'm not, I got some gross answer. This is the common answer will be said by everyone in the world who have used the thermometer but having no knowledge of engineering. Can you say something with the flavor of engineering?
Sir, please repeat the question once.
Except thermometer, which one you will prefer? Do you prefer RTD to measure body temperature? Do you prefer thermocouple to measure the body temperature? I need wrong answer, not right answer. Who can say wrong answer? If you silent means you all know the right answer. Say someone a wrong answer. Like
Sir,
Shublik. Okay, Rajiv.
a thermocouple needs both a hot junction and a cold junction, which won't be available. It can't be used to measure body temperature.
Okay. Next. Moinak Das. Can you say wrong answer? Moinak,
Yes, sir. Yes, sir.
can you explain wrongly why we will not use thermocouple to measure
So
the body?
thermocouple requires two temperatures, a hot and a cold body. Otherwise, it cannot measure the temperature.
Okay. When I have asked you say something wrongly, you started answering rightly. When I asked you something, say you know about this one, then you said nothing.
Sir,
So
in thermocouple, sir,
ah,
in thermocouple we need a large temperature difference. Yes, sir.
whatever you
So
say, okay, you can say it. Then you just say wrong answer. Huh? Okay. Say what you want to say.
sir, in thermocouple we need a large difference of temperature. Only then the difference will be measurable. Otherwise, it can't be measured properly.
Sika, Sika, Sika Saha. Suraj Soren.
Yes, sir.
Suran,
Yes, sir.
say wrong answer. Why?
Uh,
RTD is not preferred to measure body temperature. Huh? And you can Google the question, you will get the right answer. I don't want to know the Google answer. I want to know your anticipation or assumption. So that's why I said you say wrong answer. You don't need to Google it to find the answer rightly and you said this to me. Because I can Google, I can get that answer sent. So I need your perception about the instruments basically. Soren, Suraj,
yes, sir.
could you answer?
No, sir.
No. Okay, fine. Let me say. Firstly, the important thing is the range. We normally know body temperature is within 110 degrees Fahrenheit. But when we are using a thermocouples, few thermocouples can give you the output within 10 days, but it is bulky. As well as we need a cold junction compression that rightly said by one or two of your friends like Azib and Moinab. And also there is another problem that is the voltage outcome or output due to a small variation. Normally human body have a 98.97 to 97.4 is the normal body temperature, while 98 is considered a little bit high temperature or fever conditions, nearly started fever condition, 98 or more. So, look, that is a small temperature change which we need to measure accurately, and probably the thermocouple which has a wider temperature range or measurement of wider temperature range cannot regulate properly that particular difference of the temperature. So, so it is very difficult to use thermocouple. Okay. Although today the thermocouples are few thermocouples are developed such way that it can even used for the body temperature measurement, but still not up to the bar or still not commercially available to every sector to know the body temperature. Okay. Anyhow, the most popular one is thermocouple used. Few thermocouples are used, and you will find in digital thermometer few digital thermometer where thermocouples are used. But popularly, clinical thermometer or made of mercury thermometer are used. And in case of mercury thermometer, we know that kind of instrument having a sufficient rangeability to measure the body temperature maximum and minimum. So that's why it was scaled from 90 degree Fahrenheit to 110 degree Fahrenheit, within what the human body temperature actually persists. Now the question is that uh, this is a criteria or property of certain instrument which help you to select the instrument in a particular application area. So the most important part here.
Sir, you said 4 important parts of the instrument, sir. What was 2 and 3?
Huh?
Sir, you said 4 important parts. Sir, 1 was
That I
construction and 4 was application.
When you are going to say about to know about the instrument, to know about the instruments, you definitely need to know one, its images. Number 2, construction. Operation. And working principle. And what I said?
Sir, application.
Application.
And the last one we should keep in mind, that is the advantage. And disadvantage. So these are the five paradigms. Among them, 4 are important. 4 are important means whenever you know the applications in details, you will find that definitely it will have some kind of advantage and disadvantage according what it will be used. Now, whatever I want to say, so when we are going to apply an instrument, it's depend on what? It's depend on firstly its static characteristics. Secondly, the dynamic responses. And thirdly, definitely the you can say disadvantage, advantage. Disadvantage. So these are the three things you have to keep in your mind while you are going to apply instruments. Now in static characteristics, we will find there will be several points which you need to know. One like a accuracy. Precision. The term I will discuss today. Loading effect. Loading effect is not characteristic, but it's the important factor. Definitely important factor here when you are going to connect with the power supply. Precision, accuracy, drift, resolution, reproducibility. So I am coming to that point here. What are the static characteristics? Peter?
স্যার স্ট্যাটিক ক্যারেক্টারিস্টিক লেখাটা একবার দেখিয়ে দিন না, স্ক্রিনশট নিয়ে নিব তাহলে পরে।
হ্যাঁ
স্যার উপরে লেখা আছে না লাইক স্ট্যাটিক ক্যারেক্টারিস্টিক্স এর ব্রাঞ্চেস, ওটা একবার দেখিয়ে দিন না।
এই লিখলাম যেগুলো,
হ্যাঁ হ্যাঁ হ্যাঁ
আরে ওগুলো আমার হাতে লেখা স্ক্রিনশট দিচ্ছে তো ও আমার মরে যাওয়ার পর নিও ওই হাতের লেখা পড়া মানে একবারে মানে মোস্ট বিরক্তিকর এটা বোঝার জন্য পড়া এটা টেক্সট বুক পড়ে নেবে আমি টেক্সট বুক বলে দেবো তুমি টেক্সট বুক পড়ে নেবে বা আমি দরকার পড়লে নোট দিয়ে দেবো সেখান থেকে পড়ে নেবে হ্যাঁ আমার হাতের লেখা দেখে
Okay,
তুমি বুঝতে পেরেছো তো আমি যেটা বলতে চাইছি
হ্যাঁ স্যার
Fine. So now come to the point of static characteristics. So now, what are the static characteristics? Static characteristics or static performance. Static characteristics or static performance are very important to know about the instrument because of what? Because of what? We will know about certain kind of linear, certain kind of property which will not vary with the respect to time. I mean, it's remain all over the period of instrument use of instrument. It's remain almost same. It will not varying with time. Now, what varying with time? What does mean? Suppose with thermometer you are going to measure the temperature. Okay, so you put a thermometer to measure temperature like 100 degrees centigrade. At boiling point, pure water, you know it's 100 degrees centigrade. But once you inserted the thermometer, it is not showing 100 degrees. Its maximum temperature it is showing is a 97.3 degrees centigrade. So 97.3 degrees centigrade is not the boiling point of water. You know, the absolute boiling point of the water at a 1 atmospheric pressure is definitely 1 atmospheric pressure. A pure water boiling point is 100 degrees centigrade. You know. But your thermometer showing is 97.3. What can you say about the instrument? It is
So it is and
Inaccurate,
range is
we can
less.
say.
Yeah, inaccurate.
Having some error.
not accurate instrument to say the right reading, right? Or it is a erroneous instrument, or you can say the instrument might be defective. But there is a certain problem in instrument because it is not showing the exact result which it should. Then the problem is that property varying with time. I mean, if you put that thermometer 97.3 right now, it is showing the boiling point of water which should be 100 degrees centigrade. Now you use that same thermometer after 30 days. Will it show same reading or different reading? What do you expect? Will it show same reading or different reading? What do you expect?
So
Same reading, sir.
All
Same
conditions are
reading.
same.
You expect that same reading. You will say to your friends that bhai if thermometer আমি আগে ব্যবহার করেছি thermometer খারাপ আছে এটা ইউজ করিস না. You will say this kind of word, na?
yes,
Yes, sir.
So that means the property, particular this property showing the wrong result will not vary with time. So this is called a accuracy related term. The accuracy of the instrument is not good. Okay, I'll come to that point. But what I have to mean that particular property, but that kinds of property are actually not time varying. So these are called static property. So these are called static property. So static property or static characteristic of a transducer or any measurement system are established by the process of static calibration, right? Static property or characteristic of any measuring system are established by process of static calibration. Now, what is calibration? Like here I said, if pure water at 1 atmospheric pressure, it should be 100 degree boiling point. But what we have seen that it is a 97.3. So you got the error here. It is a 2.7 degree difference. Okay. What you need to know, you need to make the thermometer tune such way that it should show 100 degree. It should show 100 degree centigrade. So for what you will take certain measures and finally your system develop or your instrument develop and modified and now it can show you 100 degrees centigrade where the boiling point exactly 100 degrees centigrade. So that means there is a no error or error is 0. So this kind of measure is called static calibration or calibration. I'll come to the definition of calibration in detail, but this is a kind of calibration we did, and finally that instrument is ready to use. Finally, the instrument is ready to use. So the by static calibration, we can say the relationship between output signal, the relationship between output signal and quantity under study, and the quantity under study is experimentally determined. Quantity under study means what? Like here temperature 100 degrees centigrade, we require to measure. And output of the instrument, what it was? 97.3 degree. So the output as well as the quantity under study is experimentally determined. Measuring instrument or measuring systems respond to the quantity under study, but it is not likely to be influenced by in its performance by quantities other than the desired signal. Okay, that is a condition. That is the condition means measurement system responds to the quantity. I mean, like 100 degrees centigrade, what is boiling? So the system should measuring system should respond to the 100 degrees centigrade, but it also likely to be influenced. Also, but it is also likely to be influenced in its performance by the quantity other than the desired signal. That's why it was changed. What the 100 degrees centigrade was required, but it is 97.3 degrees. That 2.7 degrees change due to some other parameter. Definitely, what we have to do, we have to take care of the other parameters. Then we can able to make the instrument improve such way it can show the accurate reading. Okay. So in such case, all efforts should be taken to see that the static calibration is effective under condition in which all other quantities except the desired signal are held constant. Okay, are held constant.
Sir, is there any guarantee that if it shows the correct temperature for one temperature, it will show the correct temperature for all the temperatures?
Guarantee means what? What do you want to mean by guarantee?
Sir, like if it shows 100 degrees Celsius correctly, sir, can we guarantee that the instrument will show every temperature correctly, 80 degree, 90 degree, every temperature correctly?
1 minute. I have said one experiment to measure the boiling point. I have not said the calibration. I said one experiment we done. We found that 100 degree boiling point is showing 97.3. Then I have to go for some kind of static calibration or measure what the other the parameters or influencing parameters or influencing parameter other than the desired signal should be ignored or should be constant, which will not able to influence more the instruments. So if we can do this one for his span of measurement, then we can say it's a calibration. Once the instrument is calibrated properly according to the rules of calibration, then definitely that systems will work on that particular range. Remember this one. Once the instrument is calibrated according to the process of calibration, and once it is calibrated, definitely it will give you the best result within the calibrated range, not out of the calibrated range or beyond the calibrated range. Get my point? So if the instrument is calibrated, then 900 degree boiling point can be measured accurately. If instrument is calibrated with the proper range, then the boiling point, melting temperature of copper will be measured truly or accurately. Even the melting point of iron also measured truly. Okay, It's depend on the mode of calibration process, and if the calibration process followed properly within that range, then definitely the instrument will give you the accurate result or nearly accurate result. Or you can go some measurements or you will get some values with certain kind of plus minus error, but that is almost considerable. It is not at all ignorable. Now, right now, if you say someone the boiling point of water is 97.3, then that your answer will be condemnable.
Sir.
You have, if you have a minimum knowledge of science, you never say that pure water boiling point of 1 atmospheric temperature is 100 degrees centigrade. It definitely 97.3 degrees centigrade. It's definitely 100 degrees centigrade. But if you know if the pressure is increased, is that boiling point even same?
No, sir.
No, sir.
So in case of pressure cooker, you will know that due to increase of pressure, the temperature boiling point will not remain same. So if you said that 100 degrees centigrade, 100 degrees centigrade is the boiling point of water, with the 2 atmospheric pressure, definitely your answer is wrong. Or 3 atmospheric pressure, definitely your answer is wrong. If you say that my boiling point of the water is 60 degrees centigrade in 1 atmospheric pressure, definitely your answer is wrong. What kind of wrong? It might be some other parameter like the contaminated water. That's why the boiling point is now reduced to 100 to 60 degrees centigrade. It might be like that the pressure you measure is 1 atmospheric, which is not accurate instrument showing a 1 atmospheric pressure. The pressure might be less than of 1 atmospheric pressure. So there are several results or influencing parameter which actually influence your measurements or experiments. So that's why we require to calibrate in an ideal condition that instrument. Then after we can use for same atmosphere to measure some particular parameter. That's why yesterday I told, whenever we want to use for serious, we want to do some serious measurement with a better accuracy, what we need to do? I said yesterday that we need to do calibration or recalibration of the instrument. Otherwise, we may have some wrong outcome. So we need to make or season the instrument with the atmosphere, as well as we have to get the perfect balance with minimum, maximum, and linearity. Then we can measure. Now come to the point of the parameter I said. I said what? Calibration. Okay. The process of static calibration, okay, requires the presence of standard. Requires presence of a standard with which the output signal of measuring device is to be related. So process of static calibration requires the presence of standard. Now what do you mean by standard? Have you studied some primary standard of length?
So meter.
Yes, sir, meter.
Huh?
Definition of meter.
Anindita,
Yes, sir.
okay. Can you say name of any primary standard that you studied in 11, 12, 9, 10?
So there were definitions of what is considered in the SI
No
unit.
need a definition. Just remember some kind of expression of primary standard device. I'm not asking standard device.
So I can't remember now, sir.
A iridium bar kept in London Royal Society, which length
Yes,
is
yes,
1
yes,
meter.
sir.
1
It was
kg.
there, yes, sir.
Have you studied? Can you remember them?
Yes, sir, it was in.
These are the primary standard. The length of the iridium bar is considered 1 meter and it is 1 meter. And
Yes,
respect to
sir.
what we want every straight line which is 1 meter or 1 millimeter or 1 centimeter in our line. every corner of the earth. Every corner of the earth and every based on human knowledge, even in space, wherever we say 1 millimeter or 1 micrometer, it is actually calibrated with respect to that primary standard. Even in the space, even in our galaxy, even in our solar systems, even in our whatever you can say, light years, or whatever we are going to say, the distance between Earth and Sun, whatever we are going to say, the units actually comes from what? Calibrated with respect to the primary standard, which is the iridium iron bar kept ST bar kept in London Well system, which length is 1 meter. Similarly, any other standard we can remember?
So kilogram.
Kilogram. Can you say what is the details of the kilogram standard?
No, sir, I remember the one of the time.
One of the
I remember the time standard. The,
say
the frequency of some cesium or iridium element that
Yes, a
in 1
cesium
second.
atomic clock.
Yes.
Mustafa. Mustafa,
Yes,
can you say it clearly?
স্যার টাইম স্ট্যান্ডার্ড হচ্ছে একটা সিজন অ্যাটমিক ক্লকের ফ্রিকোয়েন্সির উপরে এটাকে মেজার করা হয়, দ্যাটস লাইক measured as the standard of time.
Atomic. That answer can be expected from class 8 or 10 student. But
Yes.
what kind of material used for that clock particular?
Cesium.
Cesium. Good. Cesium clock. And in cesium clock, what expected? What is the error we expect? There might be error of 1 microsecond. 1 microsecond means 10 to the power minus 6 seconds. There might be error like 10 to the power minus 6 seconds. Okay. What is the standard unit of primary unit of weight? Like Rajdeep said. Anyone from you? Tuvalil Mandal?
Hello, sir.
Tongram Saha? Can you say me what is the primary unit? Explain the primary or exemplify the primary unit of weight. Primary standard of weight. Huh? Yeah, definitely gram. But why it is with respect to what we said gram, kilogram, how it comes. Silpa,
Yes, sir.
can you say about the gram? 1 kilogram. Only Porno 1 month.
Sir, sir, it's measured to a cylindrical block which is a platinum iridium alloy cylinder.
It is kept where?
Where it is kept, I don't remember, sir. Where with the, it's in a museum, I guess. Don't remember, sir. But it's a platinum iridium alloy whose weight is taken as the standard for kg.
So it is probably kept in Paris, no?
It is already kept in
It was probably kept in Paris.
Paris, right? It is already kept in Paris and it is considered as a SI unit of mass. Standard SI unit of mass, right?
Yes, sir, 1 kg.
Okay. So these are the units, standard unit. Okay. When we are talking about certain kind of calibration, we have to say that the static calibration process is actually requires the presence of a standard. Now look, this particular standard not available everywhere. If you are going to make a weight here, it definitely not give you the primary standard. The company or the international standard will not give you that weight particular kept in Paris lab will give you and may help you to say you design your weight machine. It is not possible. So we definitely use certain weight machines which are considered secondary standard, not the primary one. Primary one are kept in standard atmosphere or ideal atmosphere in which the weights are the weight or the primary standard units are measured and it is kept there. And with respect to what there are some secondary standard and those standards are given to some companies. The companies make another standard from the secondary standards, which are even used for calibrate their product, which are used for calibrate their products where then after it is commercialized in the market. Okay. So the process of calibration requires the presence of a standard, means this kind of standard. Okay, with which the output signal of a measuring device is to be related. Okay, if it is an indicating or recording instrument, that is under calibration, the indicated value of the pointer, okay, on the calibrated scale is checked for its correctness by comparison with the standard source of quantity under the calibration. This is the important term you must remember. If it is an if it is an indicating or if it is an indicating or recording instrument. Indicating or recording instrument means what? Like galvanometer, like the multimeter, okay, like ammeter, voltmeter that you have used earlier, or the deflections actually give you the reading, okay, or some kind of recording device. Recording device you have seen printer. Printer is a recording device, but earlier printer was not available. There was a certain kind of stylus and thermographic plate or thermographic stylus. These stylus are used to make a permanent trace on the paper. Have you seen Robocop?
So the movie.
Sir, yes, sir. Yes, sir.
Or any earthquake movie?
Yes, sir.
Yes,
They
sir,
use
yes,
that
sir.
meter.
So
So you
seismograph
will
is like
find there
Seismograph.
would be certain kind of seismograph
the
where some strains
seismograph.
of
It moves on the
vibration.
Richter scale. Yes.
Yeah. So that tremor actually recorded by a stylus. Have you seen? The tremor or vibration or earthquake actually recorded by a stylus.
Yes, sir. Yes, sir. Yes, sir.
So it is recorded on a graph paper type thing.
Yeah.
So it shows the variations.
These are the paper and pen. Now pen, if you use a simple pen like your ball pen, then the ink will be required to be filled each and every time. So when you will switch on your seismograph and at night, and probably you will go for the bed for 8 hours minimum. Okay, that means within that time, if any kind of earthquake or any kind of vibration, it needs to be monitored. Definitely, your stylus will go and work on. Then, if you use the ink filled pen or ink filled stylus, then the stylus required to be filled. Or sometimes the ink not slip out clearly. That trace is not being monitored or recorded. So there is a certain disadvantage of ball pen or ink filled pen. There will be certain kind of metal stylus, and the paper was thermography. The metal stylus continuously heated up, and stylus on the thermographic paper, the metal stylus actually gives some kind of permanent trace. So you can, peacefully go for sleep for 8 hours, no issue. The stylus and pen recording system or the thermographic pen recording system will move on, will work on, and it will give you the no loss of the data. It will give you the almost zero loss data. I mean, so this kind of stylus or recording system sometimes used. Okay, sometimes there is a photographic plate, like X-ray plate you have seen, photographic plate, and some kind of radiations, monochromatic radiations or single beam radiations are allowed to give a stress on the photographic plate. That will be a permanent trace, and even that can be used as a recording device. So these are kind of recording device which require to be indicate a certain value. What we have to do, we have to keep in your mind that the recording instrument that is under calibration, indicating value of a pointer on the calibrating scale, is checked for its correctness. Checked for its correctness by comparison with the standard source of quantity. By comparison with the standard source of quantity under calibration. So this way the static calibration actually done. There was some absolute standard, as I said, National Physical Laboratory, National Bureau of Standards. Those are actually maintain that particular standards for every country as their national physical laboratory and national. And certain standard, certain absolute standard are kept in like a Paris or London, which are called international standard, which actually maintained by International Standard Association. Okay, now come to the point, some basic characteristics where we will find the error. As I said you that the first terms in my written is the accuracy. What I said? Accuracy. In accuracy. What is the definition of accuracy? Accuracy is the closeness. Is the closeness or nearness, whatever nearness of the indicating value to the true value of the one PT of the quantity being measured. Okay, quantity being what I said, the accuracy by definition is the closeness or nearness of indicating value to the true value of the quantity being measured. Any confusion in this definition? Do you say?
No, sir.
No, sir.
So what I said, somebody read it out loudly.
Sir, the closeness or nearness of the indicating value to the true value of the quantity being measured.
Very good. There will be certain kind of accuracy, span accuracy, and certain kind of accuracy will be there. I'll discuss this one in details, but before this one, let me say about the other some parameters like static error. Like static error, the error and accuracy both are both are quite related. So static error is that As I said, it is a static error. That means you must keep in your mind there will be certain dynamic error. The static having an opposite word is dynamic. Dynamic means which is varying with respect to time. So in static error, it is defined the algebraic algebraic difference between the value indicated, and the true value of quantity presents to that input. What I said, calibration static error is algebraic difference. Value indicated or the conveyed by the output or conveyed by the output, conveyed by the output means output of what? Output of the measuring systems, output of the measuring system, and the true value of the true value of the quantity presented to the input. আমার একটু লিখতে অসুবিধা হচ্ছে, তাই জন্য থেমে থেমে যাচ্ছি। তো আমি জানি না তোমরা পড়তে পারো কিনা। The static error is called algebraic difference. হ্যাঁ, algebraic difference between the value indicated or conveyed by the output of the measuring system output of the measuring system and the true value of the quantity presented to the input. True value of the quantity to the presented to the input. This is called static error. Similarly, there will be certain term is correlation. So correlation. Correlation is defined as the opposite of error. Correlation is defined opposite of error. Correlation is defined opposite of the error and the true value obtained by adding algebraically the static error or by applying correction. Sorry, it is not correlation. Correlation is variation with respect to the inputs or correlation between two outputs. So I will come to that part definition correlation later on. It has certain mathematical representations to understanding. Suppose like the two output x1 and x2, then x1 required to be correlated x2 by some mathematical definition. This particular definition will be details understand. We will have a details understanding in some statistical analysis. So this part I like to jump over the uncertainty. Better I like to jump over the uncertainty. Okay, uncertainty. So this will be discussed. দাঁড়া আমার মেসেজটা কিছু একটা হচ্ছে আমার লেখা খুব অসুবিধা হচ্ছে একটু হোল্ড করো আমি একটু দেখে নিই সো আমি আগে লিখে নেই তারপর বলি, নাহলে মুখে বলে নি পরে লিখি, যে কোনো একটা করি। লিখতে লিখতে আর টাইপ করতে গেলে একটু টাইপিং এর প্রবলেম হচ্ছে, বা আমার লিখতে গেলে পুরো একটু প্রবলেম হচ্ছে। ওকে, the uncertainty can be expressed like the range of variation of an indicated value from the true value. So first one, we know the accuracy, that is the closeness of the true measuring indicating value to the true value. Second one, we studied the static error, what the algebraic difference of indicated value and the true value. And uncertainty, which is the range of variation of indicated value from the true value, range of variation of indicated value from the true value. Okay, now come to the point of precision. Degree of refinement with which degree of refinement with the which a measure value is stated. Stated means like there is a very famous term which sometimes actual precision actually sometimes confused with the accuracy. How it is confused? Accuracy is called degree of closeness. It's a degree of closeness of the measure value to the true value, and in that case, precision is called degree. It's a degree of repeatability. Okay. Repeatability of the measure value to the close value, of the measure value to the close value. It's also related with the true little bit with the accuracy, but there is certain difference of the accuracy between the precision. How they differ? Let me take a example of accuracy and precision. I like to explain it. Then I'm going to say something like that. Precision defines that what the degree of refinement with which a measure value is stated. Okay, if an input quantity of the same value, consider if an input quantity of the same value is applied repeatedly to the instrument under exact the same environmental condition, the indicated value is expected to be same. Get my point?
Yes, sir.
Yes, sir.
How? Can you explain it?
The precision is basically the repeatability, as in like the number of times we measure it in every time should come the same.
Now, not only repeatability, it is the exactness of the repeatability. I mean, repeatedly I will do the same work, but I will produce same output. If I will my experiment will be conducted first time, it will give you 97.3 degree centigrade, the boiling point of water. Fine, it's erroneous, it is inaccurate, right? You know. And after 30 days, we again measure the boiling point, absolute boiling point of water in absolute ideal condition. It's showing you 97.3. Again, after 5 days you measure, it's again showing a 97.3. It again after 10 days you measure, it's showing 97.3. What does it mean? 4 or 5 experiment you did, and you will find the same output for same input. What does it mean? The accuracy is changed? No. That it is same inaccurate, and at the same time it is highly precised. It is highly precise because all time with the same experiment it will producing same output. Okay, but accuracy is less. The instrument have a less accuracy but high precision. Sometimes by English language we used to say your answer should be precise. Precise mean we sometimes use this way that your answer should be accurate. And accurate, he will hit the right answer. But precise means precision means not only that it should have an accurate result, but whatever you are going to say, you will not change in future. So precision means whatever the reading showing by your instrument might be less accurate, but it has a great precision or repeatability that every time you will do that same experiment, it will give you the same outcome. But if you think that your instrument showing right now is the 97.3 degrees centigrade boiling point of water, and after day after tomorrow it will show the same experiment, same input, same environment, showing the output reading is 98.3, and next day you did the same experiment, it is showing 99.3. Next day it is showing 95.6. Next day it is showing 90.1. Then if you will find the characteristic of instrument, you will see that it never reached to the 100, so it is not at all accurate. Rather, it sometimes shows 90 degrees centigrade, which is much more less accurate. Okay, much more than less accurate. Laser accurate, and not only that, but if you talk about the precision, it never repeats the same output. It never repeats the same output, or never repeats any output which is same with the earlier one. It never repeats the output which is same with earlier one. So the precision is less, accuracy is less. Okay. Now you got a instrument which first day measure boiling point of water is 100 degrees centigrade. Second day it measures the boiling point of water 103 degrees centigrade. Then day after that you measure again the temperature of boiling point of the water. It's showing 99.8. Again next day we measure it is showing 99.99. So this way. Then you can say the instrument has a greater precision, better precision, but highly accurate. Better precision, but highly accurate. Better precision means all the outputs are within a particular range where the input state. Input state is 100 degrees centigrade, and the output of the instrument is sometimes 101, sometimes 99.99, sometimes 98.99, sometimes 107. So this is the range where the accurate reading used to be. So it is better precision, and not only that, the reading is very close to the correct one, close to the true value. So it is highly accurate. Okay. The instrument is high accurate as well as better precise. First one is a highly precise but less accurate. At the middle example or the second example I am giving, where the accuracy and precision both are zero or bogus. And the last one I said the instrument is accurate, highly accurate. Not only that, is highly accurate or better precise. Better precise. Not I will say is accurate, highly precise, because the earlier one always giving 97.3. So that instrument is highly precise, but here the instrument is giving different kind of reading. The reading is very close to the true value, so we can say that it is highly precise, better precise. So these are the difference between accuracy and precision. So as I said, that precision is the degree of refinement within which a measure value is stated if an input quantity same value is applied repeatedly, input quantity of same value applied repeatedly to the instrument under exactly same environment condition, same environmental condition, definitely like 100 degree pressure, oh sorry, 1 atmospheric pressure, 2 atmospheric pressure influence the boiling point. So the same environmental condition will require to be here, and indicated value is expected to be the same. That means it's highly precise. But in practice, the reading will be clustered around the, what is it? It's clustered around what, 100 degrees centigrade. So we can say the in practice the reading will be clustered around a value in a random manner, from where we will get the average value. Okay, so an accurate measuring system should not be precise as there is no point in attempting to obtain high precision for the instrument in which an accurate measurement system should not also be precise as there is no point in attempting to obtain high precision from an instrument which is inherently poor in accuracy. Okay. So this is all about the precision. You keep in this mind, sometimes in exam, the commonly question asks what is the difference between precision and accuracy. Even our grand viva, even our laboratory viva, the question were used to remain same. What is precision or what is precision or what is precision? Difference between precision and accuracy. Now come to the next static characteristics.
Sir, could you explain the last thing once again, sir? An accuracy measurement system need not be precise because?
What I said in last statement?
Sir, an accuracy measurement system should not be precise because the reason I'm asking.
If the system is not, the reading is not accurate every time, it's a poor accurate, that means there will be certain difference. Like the last one I said better precision. Last example I said better precision. Because the accuracy here you will find that is varying. The first one I have given example that the instrument repeatedly producing 97.3. Okay. But as we find that the reading is same here, the precision is high. If the reading was centering at 97, not at all centering at 100. I mean, every time the system is saying that 97, 96.8, 98.8, 97.3, 5 point something. So it might be centering at nearly 97. Okay, the accuracy is 4. At the same time, we'll say the precision is 4. It's not at all good. Can I say it?
Yes, sir.
Now when a system is measured, sometimes should be precise. When it is precise, highly precise, might be the accuracy poor, but every time it is showing 97.3. Every time, every experiment it is showing 97.3. Then the accuracy of accurate measuring system should be precise. I mean, then the measuring system should be precise. Now, in the second example, what I said that the result is 100 degrees centigrade. And what about the precision? The all the experimental result actually centering 100 degrees centigrade, but it's varying. So that is accurate measurement systems with the precision, with the certain precision, not better, but it's highly precise, right? So that's why I said an accurate measuring system should be precise. How can you say its system is accurate? Statistically, you have to do number of experiments in physics laboratory first year, or you have not done the first year laboratory here. Only you done that by software, but in HS level probably you did the experiment, right?
Yes, sir.
Certain measurement you done with 10 number of reading or 20 number of reading. Right?
Yes, sir. Yes, sir.
What you did that time to find the value? You did some kind of averaging.
Yes, sir. Concordant reading, otherwise average.
Mean value of that one. Suppose your reading was mean value of the reading was near to the accurate value or true value. Then what you can say? The
Then that
instrument
is
is accurate or
accurate. Yes, sir. Accurate.
now that can be achieved by what? Having an average value of the 20 number of experiment.
Yes, sir.
Yes, sir.
If that 20 number of experiment will give you the a random data. Random data means which is random in nature and they are not even close. Then whether your output or mean value will be close to the true value?
So it will not be, sir.
It will not be. Why? Because that nature, the precision of the systems or experiment was wrong. Poor. So numbers of time you did the experiment 20 times, but your reading was so abruptly different. Okay, for what you cannot say the average value which you have, you should be close to the true value. So when you will get the average value close to the true value, when you will find the number of experiment you did, and according to what the results comes very close to each other, and finally you got the average, and you will find that average is near to the true value. One of the example is that when you have drawn a straight line graph, look, I'm just drawing a picture like here. You did a measurement value, which actually true value here. This is true value. And what you done? You done 20 number of experiment. 20 number of experiment. One experiment is here. One experiment 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 here. One value here. So if you got this one, every point have x value, x1, y1, x2, y2, x3, y3, x4, y4, and so on, and so on. Then you will get a average value x mean and y mean. What will be that? x1 plus x2 plus so on by n. Similarly, y1 plus y2 plus dot 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 by n. Am I right?
Yes, sir.
This
Yes,
will be
sir.
your average value. Now check that average value got a position here. And the most of the data is here, so the average value will be here. This was your true value. And this was your average value. And the difference between them is delta. If delta is high enough, difference between them is delta. That is static error. That is static error. Okay. If static error is high enough, will you say it is accurate?
No, sir.
No, sir.
No, sir.
Inaccurate.
Inaccurate.
Now look the randomness of the data you did in experiment. Why the average value is here? Because the randomness, the
Yes,
data cover a wider range. Data cover every time the output data cover a wider range. within a wider range. That's why the average value shifted from true value towards the, I mean, from true value to somewhere else, not close to the true value. If that same experiment done by your friend by another experiment setup and the whole reading was close here, then what is your expectation? Average value remain in this position. Average value remain in this position, right? Because most of the data is clustered here. Most of the data is clustered here. I mean the
Yes, sir.
randomness or discreteness of the data is not too high here. All data, or every time the experiment, the data produced by your systems or output of the data remain in a close contact. So that's why average will be here. And not only that, average will be here, the average value is close to the true value. So we can say it's an accurate measurement system because the accuracy is much more better than of that system. Not only that, it is highly or better precision. Okay. One example of that one, তোমরা যখন মেলায় গেছো, you have seen that there was a balloon and you used to fire the balloon or you used to blast the balloon by your gun, air gun.
Yes, sir.
Okay. Some of your friends may hit the balloon every time rightly, and some of your friends hit side of the balloons, not the balloon exactly. So if you talk about the precision, the first one have a high accuracy, high precision. Second one has a less accuracy, poor precision. Okay, and some of your friend hits not only the balloon, also the chopper. That means it might have a certain kind of accuracy, but about the precision, horrible. It hits out the chopper, it hits out the seller. Okay. So this way you can say there will be certain difference between accuracy and precision. Okay, when you will read this one, it is very small thing. What I spend more time to explain this one rather than it was written in the book. To come to the next point. Next point is reproducibility. So what is reproducibility? The closeness with which the same value of input quantity is measured at defined time and under defined condition. Earlier we consider the same condition. Defined condition, uses of the instruments and by defined instruments. So there will be certain difference between the reproducibility and precision. Reproducibility have a defined condition, a defined instrument, still it is producing same reading. I mean, suppose you want to change a needle of the a sewing machine, you will find the same output is coming out still after change of the needles. Okay, so this kind of different instrument, but help you to get the same output by the experiment. It's called reproducibility. Another important term is stability. This is one of the important terms. Stability. From the stable condition, it comes stability. A instrument required to be stable. Why it is required to be stable? Suppose some kind of installation, some kind of wrong installation. What happened? The instrument may give you wrong output. The wrong installations mean what? Suppose you want to put a microscope on a balancing machine, a microscope on a particular pointing platform. Should we give you the right image? Definitely not, because this platform is not stable. It's the pointing platform. So the microscope cannot be stable. So once it will not be able to stable, it will have a certain kind of vibration. Even vibration is very small, but due to the pointing or due to the edge of the upper surface of the platform, the systems will have some kind of unstable setup, and will give you the wrong reading or hazy or blurred images. So what we need? We need to put it in a stable setup. We need to put it on a stable setup to get a perfect images. Like your camera, when you are going to take a long view through a camera or long image, nature image by your camera. That time what you need? You need a stand. Why? Why you need a tripod stand? You need to make your camera vibration free. Okay, as if no tremor, no vibration can make the images blur. If there will be vibration, then your tripod, even in small level of vibration, then that vibration can be sustained or can be prevented by your tripod. You cannot prevent by your hands, because your breathing, your small shake of your hands can make the image blur. Okay, so that's why you use tripod, right? So these are the important term of stability. So what does it mean of stability? In engineering, in instrumentation, there is a huge or most important subject is control system engineering, as I discussed earlier. And in control system engineering, you will find the main is stability. Why should we develop a better control? To get a stable output, stable and error accurate output. Definitely stereo, accurate and precise output. Definitely the system should have a high reproducibility. Now let me know about the stability. What is stability? Stability means the ability of the measurement system to maintain its standard of performance over prolonged period of time. Not only that, even of the variation of input signal. What is the stability? Now, stability is the ability of a measuring system to maintain its standard, what I said, standard of what? Its standard of performance. Standard of performance over prolonged period of time and with some variation of prolonged period of time and variation or disturbance, variation or disturbance what I said, the ability of measuring system to maintain its standard of performance over prolonged of time. And with and some variation over prolonged of time and some variation or disturbances from input side. This is means what? If I will change the inputs but output will not change, it will get a stability. Not only that, it will stable for with respect to the time. Not only that, it will stable particular that time. It is stable for long period. It will achieve a long period stability. Long time to stability. Long time stability. Okay, I mean stability as well as durability. But the variation of time is definitely will be there, and also the variation of input or some alteration of input, the output not able to output of the system will not change drastically. That is called stable. Okay. Now come to the zero stability. There will be another definition which is called zero stability. What is zero stability? This is ability of an instrument to restore to zero. Restore to zero reading. Restore to zero reading after after the input reading has been brought to 0. So zero stability means if we make the input 0, then output expected to be 0. If we make the input 0, output is expected to be 0. What I said?
So if the input is brought to 0, the output will also be 0.
Like in op-amp, earlier example, what I seen in op-amp, we have connected 2 input, 1 output, right? This is output. These are the input 1, input 2. Minus plus. If we make it 0, if input is 1 volt, gain will be 10 to the power 6 volts, so output expected 10 to the power 6 volt, which is not possible. So it will be plus 10 volt or minus 10 volt. If this is 1 volt, it will be minus 10 volt. Okay. Why it will be minus 10 volt? We connected here minus VCC, that is 10 volt. Minus 10 volt, and there is a connected plus VCC, that is plus 10 volt. So output will be saturated at 10 volt or 1 volt. Now I just make this one 0, like this one 0. So what should be the output?
0, sir.
We expect the output should be 0. But practically, you know, that will not be 0. So that means if you talk about the zero stability, theoretically it should be zero stability because V0 equal to AD or A into VD, differential voltage. VD 0, so output should be 0. But that is not possible in real condition. Real of it. Zero stability will not be there. Why? We know IC, I consider, but IC is ICO plus ICE. Am I right? IB equal to IB IBO. So we'll find there will be, if we make that VD is 0, still there will be a V0 or some X millivolt, which is called offset voltage. That's why the op-amp 741, the picture I have shown you yesterday, 1, 2, 3, 4, 1, 2, 3, 4. So we know 2 and 3 and 6. 6 is output, 2, 3 are input. If we connect that 2, 3 ground, output you will find after certain time it will be having certain kind of millivolt. That is the X millivolt. Now why? You will find there will be some kind of offset. Or due to what we have to connect this terminal which is 5 and this is terminal which is 1. It's called offset nullifying terminal. Terminal. We have to connect a resistance across this one or a opposite voltage of small order to nullify that voltage. Otherwise, you will find there will be output voltage. I mean, about the zero stability, real op-amp never will give you zero stability. So there is a need to develop another open circuit which is called instrumentation amplifier. Which is called instrumentation amplifier. Which has common mode rejection ratio. Very high. What do you mean by common mode rejection ratio? Common mode means two input here, I make them common ground. I make them common ground. Two input here, I make them common ground. Like earlier top of the picture, I have said is that two input, I connect them to the ground. I made them common ground. And at that time the output voltage I found still some value. But what I expect, it should have a zero stability. But as it is not achieved, so we have a certain configuration where the output should be minimum as possible. As minimum as possible. Because we require to ignore the output that time. That is called zero stability. Okay. Now come to the another point.
Excuse me, sir.
Ah.
Sir, actually we have a class after some time and we haven't had our lunch, sir. So the class will go on till 4.
So should I stop here?
Yes, sir, that would be better because none of us have had our lunch.
I too.
Yes, sir.
Silpi. Anindita, who was speaking? Anindita, na?
Yes, sir, yes, sir.
Okay. Just 1 minute, hold on. Who is next teacher right now?
BD sir.
BD, sir.
BD sir.
Yes sir.
Yes, sir.
What BD sir teaching?
Digital electronics, sir.
Hold on. When the class will start?
3 sir.
3 o'clock.
Yes sir.
Anindita, Arnav, Sudha Satto, you were silent today. What happened?
Sir, I spoke so much, sir. Where was I silent, sir?
Mustafa, Savaj Parvez, Rajdeep, Udvas, Sangram, Subhajit, Obhirup Kabiraj,
Yes.
Ankit, sorry, Ankit, Mohsin, and Mainak, Onik, Oniket,
Yes, sir.
Yes, sir.
Anirban, Suraj, Obhijit,
Present, sir.
Nilargo Roy.
Yes,
So
sir.
it was fastest, Nilargo. Huh? It is fastest. Somik Chaudhuri.
Yes, sir.
Okay. Nilargo. Or should I consider your microphone is not working, right? Although I know you was not there.
Hello.
1 minute, just hold on. Actually, what I am doing, I am taking a twin skin and circling who was there, who was not. I am need to circle the Nilargo. Somik Chaudhuri, Sagar Chaudhuri, Sandeep
Yes, sir.
Arno, Abhirup Saha,
Yes, sir.
Yes, sir.
Surya Datto, Surya Datto,
Sir, his mic is not working, most probably.
Yes, sir. He had messaged me, sir, in WhatsApp.
Om Kanji, Parvez Malik,
Yes, sir.
Yes, sir.
Gulshan Poddar,
Yes.
Silpa Mondol,
Yes, sir.
Yogesh Tiwari,
Present, sir.
Nishant,
Yes, sir.
Block,
Yes, sir.
Rajiv, and Sanjay Mondol. Sanjay
Yes, sir.
Mondol.
Sir,
Sanjay.
Srinjay's mic is not working, sir. He's writing in the chat box.
Yeah. This is the easy excuses. Okay. Saurabh Sen.
Yes, sir.
Okay. Have a good day.
স্যার
Ani.
স্যার বলছিলাম যে রোজ স্যার যেই পোর্শনটা পড়াচ্ছেন ওটা নোটস দিয়ে দিবেন তাহলে পরে পড়তে সুবিধা হয়।
হ্যাঁ ঠিকই বলেছো, একটা কাজ করো, ফান্ডামেন্টাল অফ ইনস্ট্রুমেন্টেশন পিডিএফ ক্লিক করো, দেখবে নিউ বাটের বই পাবে, লিফট ট্যাগের বই পাবে। লিফট ট্যাগের বইটা পেলে তো খুবই ভালো, ডাউনলোড করো, দিয়ে প্রথম পেজ থেকে পড়া শুরু করো, প্রিভিয়াস পেজ।
স্যার নামটা কি বলবেন?
স্যার কোন বই স্যার? চ্যাট বক্সে লিখে দিন স্যার।
স্যার নামটা একটু লিখে দেবেন স্যার।
বেলা ডি লিফট ট্যাগ তুমি না, বেলা ডি লিফট ট্যাগ।
স্যার চ্যাট বক্সে লিখে দিন না স্যার, বোঝা যাচ্ছে না স্যার।
লিখে দিন
স্যার বোঝা যাচ্ছে না স্যার, বোঝা যাচ্ছে না। ওকে স্যার।
তো এটা শুরু থেকে পড়লে পুরো হবে, মানে সব আছে এটাতে, পুরো সব অ্যাকর্ডিং টু সিলেবাস।
হ্যাঁ
অ্যাকর্ডিং টু সিলেবাস পুরো এটা পুরো আছে এটাতে, মানে পুরো অন্য বই রেফার করতে হবে না স্পেসিফিক টপিকের জন্য, এরকম কি?
One minute, hold on.
আমার ব্যাটারি শেষ, স্যার আমি লিভ করতে পারি?
Ah. So let me tell you that Biladi books, the cost of the, price of the books, process measurement and analysis by Biladi Liptop, actually 10,000 rupees around.
Sir, 12,000.
12,000?
12,000, yes, sir.
Yes, sir.
It's a huge book, and it is the master book of instrumentation. You will find everything over here, not according to your syllabus, to the syllabus of instrumentation across the world. Okay?
Okay, sir.
But we have to select some area where you have to study. But to increase your knowledge, this book is an asset.
Hello, sir.
For your knowledge, this book is an asset. So you get it, download, study the static characteristic as well as block diagram of instruments from here. And another thing what you can do is that
Sir, is it available in the library?
you will find 1 or 2 copy there.
So this is a 3-set book, so do we need the 3 other 2 books also for later?
You will find here, she said, well, the process measurement, that book is important right now. There are several other instrumentation handbook. And another thing, what I say is the fundamental of instrumentation. Let me see. Okay, is there any book?
Sir, Wiley Publications.
Let me see. I have to check that is there any books available where. This is one PDF book I found here. This is an important book, PDF book. I don't know who was the writer. Let me know the writer. It is a 337 page. It is 555 page. This one is the DOE fundamental rules. Another is fundamental in the process control curriculum. Let me see. All this is one PDF book available on the it is a very good book. I think very good book. It was written by several engineers, edited by Dominic Placo, and you will find details of instrumentation of every kind of instrument. The chapter is written someone, so that books in details. That is available. Also, William Dooney, that is also good book. And this was written by whom? So you will find there are several books like this way available on the website. So take one of them and start reading. Okay. If you are not satisfied with the books, then ask me another book. I will suggest another book. Okay.
Sir,
is it Nakra and Chaudhary better?
Nakra Chaudhary is better. But better you start with any one of the books. What you need to know, you need to study. Okay. Find out what is wrong is there. There will be some wrong in the concept.
Sir.
There will be something is not matching your concept. Then you ask me, sir, this was written there, but it is defined in other book. Then it will be better to switch to other books. At the same time, you will read more than one book. It will help you to make your knowledge better. This is basic concept of measurement. Who has written these things? Static dynamic regulation measurement. These are the book to get an immediate idea. I mean, just very short way you will get the idea. When you read the lip tag like those books, you will have some details idea. DBS Murthy, you will get some details idea. Okay, this kind of notes also help you to know something very short in a short time of, short span of time. You can read. Okay. Anyhow, I have shown you some books available on the website, so you can take them and read it if possible. And Belady Lipton is the mother of the instrumentation books. Most of the books written from there.
Okay, sir.
So what is PDF version, sir?
Is it not available on the website?
Yes, sir. Available, sir. Got
Yes,
it.
sir, got it.
Get it?
Yes, sir.
Okay.
Okay, sir.
Yes, sir. Thank you.
থ্যাংক ইউ স্যার
থ্যাংক ইউ স্যার।
ভাই বইটা দিয়ে দিস ভাই।
ভাই 12,000 টাকা কি ভাই?
ভাই
বাড়ি শরীর কিডনি বডি বিক্রি করে কিনতে হবে।
আমার কম্পিউটার ঠিক হয়ে যাবে ভাই 12,000 টাকায়।